Testing. Testing 1, 2, 3. Okay, it's good. So we are early. We will start a few minutes after 1 o'clock. I mean, yeah. By the way, can you see the text here? Yeah, it is a little small, but don't worry. I'm going to write everything on this page. And the note that I asked for, I will write everything on this paper. At the end of the semester, I only ask you to send in the note that we have here, or only a few of them. No, you don't need to have any textbook for the class. What we need to have is just the MyMathLab. I guess I'm going to write out what we have here. Right, if you have any question, yeah, please type on the chat. I certainly... Yeah. Okay. So that the homework, the textbook, and the homework question. You only need MyMathLab for homework and test. As far as for the homework and the test, the deadline, those two is due on the last day of semester. And that is May the 14th. Right. And the homework is 15%. The test 45%. Of course, you have this on the syllabus and then also on the video that I sent out a few days ago. But that's what those two together on MyMathLab and the deadline. So that's what we have. Right. The final exam, I don't know yet, but will be, if the school all open, it will be in class. If the school is still closed, we're going to take it on the e-campus. But I'll let you know when we get there. What I'm sure is about the note. The note will be 10%. So I'm asking you to write out the note. At the end of the semester, I'm going to ask you to send out some part of the note. For example, I ask you to send out the note on page 17 on the part where we do example C, for example. I ask you, the section will be clear. For example, I ask you subsection 2, example C, write out, send me back the note, including that part. It will be very clear because the way I write the note, the section, subsection, and example, everything is clear. I'll ask you only send that part in, and that is 10% for your class. So for 10% of the copy of the notes, not all of them, only a few. Right. And the final, either in class or on e-campus. So for now, to be determined. All right. Do you have any question before we go to the first section? Right. Let me rewrite this. Yes, the test is on my MATLAB. I did not post the test and the review yet, but when the test is posted, you will see will be only 90 minutes for a test, and then you have 2 attempts. So there's 90 minutes for the test, and you will have 2 attempts. The extra credit is the 3% for the core artifact. I haven't sent that yet. So yes, there is extra credit. Let me write this. So this is an assignment that I will send out to you. It's very, very simple. It's more like a survey, and you answer all of that and send it back to me. That will be 3%. I will send that out for you. The first test. So this is the kind of the schedule that I'm going to be. So apparently we will meet Tuesday and Thursday every week until the end. So pretty much we only meet for 13 days, and we try to cover 30 sections. So that will be a lot. But this is kind of a tentative schedule. The test will be right after we finish chapter 3. By the way, as mentioned before, on the test due on the last day of the semester. So if you want to, you can take all the 3 tests on that day, but I don't recommend it. We will not dedicate any time in class for the test. Right. So due on the last day of the semester for both of these 2. So homework is due on that day, on the test due on that day. And any other question, if you have, please put on the chat and I'll see and I will reply. And we'll just write everything in here. Of course, you have a copy of the syllabus also. Right. So let's go over the plan real quick. Oh no, I will not ask you the note on my MATLAB. Whatever you do the homework, you just write whatever. What I ask you is, I only ask you for the class note. Copy of the note. This is from lectures. And that is for the written note from lectures. Yes, I will have a review before a test, so you will see what kind of question will be on the test. It will be very similar to the test. Yes, I haven't posted the review yet. I only post the homework for chapter 1, 2, and 3. But you will have a review before test. So we have 3 tests, so we have 3 reviews. Attendance, it will be very difficult to take attendance, so that's not part of the class. What I ask you to do is, please go to eCampus. This is very important. Go to eCampus and the discussion board and reply to I'm going to need everybody to do that. Just go to eCampus discussion board and introduce yourself. Just click on that, read my introduction, and then just reply to it. That's just for the attendance. That just certify that you attended the class. You don't have to do that every day. Just introduce yourself the first day. That's all I need. What I ask for the attendance or participation is the note here. Remember, the note that we have is on the video, on the video lecture live right now, and I ask you to to take the picture of some of the note that you take. That obviously you either have to be here or you watch the replay of the video later. You should have some note, and then I will ask for that later. Right. Any other questions? Oh, you do not need to write to bring out the note, because I sent a survey earlier, and not many of you have the printer. Besides, we have about 80 pages, so you do not need to bring out anything. Yeah. Everything you need to write, it's just on the blank paper, like what I'm doing now. Yes, I'm not going to write everything in the note. I'm just going to write some important things, and whatever I write there at the end of the semester, I'm going to ask for some of it. You see, I'm not going to write everything I have. I'm not going to write everything I have here. That's just too much, and it will be a waste of time as well. Do you have other questions? Right. So we will start section 1.1. By the way, on that side, whenever we go to the next section, I will update the section to make sure that we know what section we are on. Oh, the copy of the note. Let's say I may ask you to take a picture of this and send it back to me. Not the picture of what I'm writing, but the picture of what you're writing, right? So I may ask you to take the picture of this part on your note and send it back to me at the end of the class. Right now, I don't know what part I will ask for you to send it back yet, but you should write out a lot. So later, when I ask for it, you will have it. Right. Your grade will be based on the complete note that you send. No, that is the point. Because if I'm telling you, I'm going to ask for a copy of this part, then you only need to write that part. What I want. No, it is at the end of the semester. So you write everything you write down. Just keep very clear. And then at the end of the semester, I will ask you send out what you write on section 2.3 example 1, for example. That I will ask you that at the end of the semester. So make sure you keep on the note organized. Right. So that to ensure that you will participate in the lecture. Yeah, I will tell you that in writing. At the end of the semester, I'm going to list like you have the list of what I asked for as a copy of the note. For example, a copy of section 2.3 example 1A, for example, and then you just take the picture of that part, and then probably about 10 of them or so. Yes, if you want to bring out the note, it's perfectly fine. Yeah. For example, if you bring out the note like what I have here, and then on that part, you just write your what we have here, and then you take the picture of that part, which is perfectly fine. Yeah. Yes, the video will be replayed later. Right. So if you bring this out, perfectly fine, and then you can write. I only ask you to write the part for the examples. I will not ask you to write all of this again. All right. Yeah. If you want to bring this out and then write your answer here is fine. I only ask you for the copy of what you have for the examples. Right. 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 Let's go back to this. One more thing. It is kind of important. So, usually a trigonometry class is 3 credit hours. Three credit hours. And if it is a 16-week, meaning that we have 3 hours a week. But our class go to 8 week. Then that's supposed to be 6 hours. Right? And now that we lose a week before this, actually now we go only down to 7. So it will have to be even more than 6 hours a week. But what we only have is 4 hours on the video right now. So my point to say, what I try to say here is we might have to spend more than 2 hours on Tuesday and Thursday to catch up, because we have a lot of hours. Originally, the class is set to be blended, meaning that I'm going to assign something for you to watch online. But since now everything is online, I'm going to need a little more than 4 hours a week. So our meeting, not on the first day though, just give you the heads up. We might have to meet like 2 hours and a half a week instead of 2 hours just to catch up. Otherwise, we won't be able to go through all the material. Right. So each meeting might be more than 2 hours. That's what I try to say. I try to have enough time to cover everything though. Anyway, so let's go to the first section. Right. And the key here is just to be organized. I'll write down the date. Right. At any time, if you have the question, please put on the chat. I will check it constantly. So, what we have is, I need a ruler, just a second. We have a line like this extended on both sides. So that is called a line. What we will have is a ray. So we're going to pick one point, and that is the end point, and we'll take either side. Let's pick every point on the right hand side of the line. So that is called a ray. So we have one end point and the other side extended indefinitely. Right. This is called the end point. And now if we rotate that ray, so we rotate an angle. Let's say rotate counterclockwise. In that case, the original ray is called the initial. And whatever it rotates to is called the final or the terminal side. Terminal side or terminal ray, it doesn't matter. So we have the terminal side and the initial side, if you will. Just rotate, and that's an angle. And then we call the end point, then is called the vertex. So the vertex is the end point where we rotate a rate. All right. As a convention, counterclockwise is positive, negative is clockwise. So positive is counterclockwise, and negative is clockwise rotation. Right. 2. Degree measure. By the way, you see this one clear, right? I don't need to zoom in or out. Might zoom in a little bit. Yeah. Right, so keep going. A definition. Since I asked you to send out pocket or note later, so I write the section, subsection very clear. So later on, when you go back to, you know where we need to look for the note. Right. So if we have one complete rotation is 360 degree. So we say 360 degree is equivalent to one complete rotation. And by default, it's always counterclockwise to be positive. Because of that, when we define 1 degree, it is 1 out of 360 per complete rotation or revolution. Right. Classify angles. So we have the following. Acute angle, that from 0 degree to 90 degree. By the way, we will use this symbol a lot, and that is theta. The Greek letter theta. And so less than 90 degrees, so it will look like this. Next, a right angle. Where it is exactly 90 degrees. And we use this symbol for 90 degree. Obtuse. Is anything between 90 and 180 degrees. So that obtuse. And then the straight angle. Where it is equal to 180 degree. And then to say, of course, it is possible to have an angle instead of go like this, it's possible to go on the outside like this. Of course, the angle can be like this too, but we just not define this to be any of this. So this is just an angle, but we just don't name it to be any of this. Right. Next, complements and supplements. Right. So we define two things here. Complement let me just write the definition. Two positive angles are complement if they add up to 90 degrees. So complementary angles add up to 90 degrees, and by definition it have to be positive. This might be important later. And then we have supplement. Again, two positive angles are supplement if their sum is 180 degrees. Again, only define for positive angles. Later on, it doesn't matter. Could be anything. But for now, the angle must be positive. Right. The examples. Find the complement and supplement for a given angle. Right. The first example, we have 73 degrees. By the way, if I'm writing too fast or too slow, please type that on the chat too. This is my normal pace. I could go faster or slower if I need to. Right. So, if the angle is 73 degrees, first the complement and it says that complement angle add up to 90 degrees. So the complement, I just check 90 minus 73 degrees. Don't forget, we always have to write the degrees, and that is 17 degrees. And then the supplement supplement add up to 180. So we'll subtract 73 from 180. And that gives us 107. Right. Next I have 110. Degrees. For the complement, we subtract from 90 degrees. And we do that, we have negative 20 degrees. But our definition, the angle have to be positive. So in that case, there's no complement because the angle is not positive. Like I said, that is the definition we have for now. Later on, we will, the angle doesn't have to be positive. But for now, by definition, have to be positive. So we subtract from 180 and give us 70 degrees. Right. Yeah. So this is on the sample. Later on, at the end of the semester, I may ask you to write the note for section 1.1, example 2D. I only ask you to send me the copy of the note, particularly in the examples, because example is the only thing that we write on the note. Right? So that was what we have for complement and supplement angles. Next, decimal degree and the degree minute and second. That's called DMS. So we define 1 degree is equal to 60 minutes and equal to, and 1 minute is 60 seconds. Or here we say 3600 seconds. And this is called a minute. And this is the seconds. Right. Example. Let alpha be 46 degrees. (42 minutes) and 12 seconds. Beta 31 degrees, 54 minutes and 17 seconds. By the way, we use a lot of Greek letter, and so this is alpha and this is beta. Right. First, find alpha plus beta. Right. So we're going to do this by hand. First, alpha 46 degree 42 minutes and 12 seconds. Beta 31 minutes 31 degrees 54 minutes. Sorry, that is the minute. And 17 seconds. Right. We're going to add them. Right. Right. So we just add them. First, just like when we add from right to left. First, 12 and 17, that is 29, right? So we have 29 minutes. Next, we have, 29 seconds. 29 seconds. Next, we're on to the minutes. 52 plus 42 plus 54, right? So that's going to be 96 minutes. We worry about that later. Just now, we just add them. And then the degrees. 46 and 31, that will be 77 degree. Right? Now, the 96 minutes is more than that, just like an hour. The clock, we're not going to talk about anything that is more than 60. So we have to subtract 60. So we still have 29 minutes. 96 minus 60, so it's 36 minutes. 29 seconds, 36 minutes. And since we subtract 60 minutes, which is like 1 degree, we're going to add 1 degree here. So we end up with 78 degrees, 36 minutes, and 29 seconds. Right. Let's see how we use that on the calculator. By the way, I think I sent out the link from TI where you can download a calculator like this. Right? So, here's how it goes. First, above the application button, you see the angle, right? So hit second angle. That's what we have. All right. So now, first alpha 46. I will hit second application 46 degrees. 42 second angle, and that gives us the minute. And then 12 second is not there. So quick. Actually, the second is the quotation mark, which I'm looking for here. Alright, here you see the quotation mark above the plus sign. So second, the plus sign. I'm sorry, not second. Alpha and the plus sign. So 12 seconds, right? Now, next, 31 degree 54 minutes and 17 alpha plus for seconds. Right, we have that. Right, how do we change that to degree, minute, and second? So second angle, option number 4, go to degrees, minutes, second, and that's what we have. Right. Next, what happens if we take subtract alpha? Now we want alpha minus beta. Right, now we subtract. To subtract is like what we do with numbers. First, we look for the second. Can we subtract them? We have 12 minus 17. Doesn't look like it will work. So it's not enough. If it's not enough, we have to borrow 1. So instead of 42, use orange here. Instead of 42, go to 41, and we bring the 1 minute to there. So we're going to add 60 to it. So instead of 12, it's going to be 72. So we're going to add 12 by 60, and we borrow 1 from the previous place. And then we can subtract. 72 minus 17, that is 51. I'm sorry, 2. 55 seconds. Right? Now, next, focus on the minutes. 41 minus 54, that's not enough. So we have to borrow 1. Turn out to 45, and we bring the 1 to the next one. To the next place. 1 degree is equal to 60 minutes. So I'm add 60 to this, and that becomes 101. And then 101 minus 54, it's going to be 47 minutes. And then 45 minus 31, so that perfectly, we don't have to borrow anywhere. 45 minus 31, so it's going to be 14 degree. Right? Now, of course, we can enter everything again, but if we're using the TI-84, all we do is just go up. When it is highlighted, hit enter, we copy and paste, and all we need to do is just go back and change the plus to the minus, and we subtract them, right? And finally, convert this to degree, minutes, second. And that's what we have. Right? So far, so good. Next. Oh, number 3. That is the 3 lowercase Roman numeral complement of beta. So we do is just take 90 degrees minus beta. I'm just going to use the calculator here. So the B is 31.54, so take 90 degrees. And subtract B beta, that is 31 degrees 54 minutes and 17 alpha plus for seconds, and we have that. Right, and you see, why is that negative? It's not supposed to be negative, right? Because the 990 is minus 31. So in that case, just go back and delete this 90. Right. So if you just enter 90 degrees, just enter 90, don't put a degree next to it. Right. So let's convert this to degree, minute, second. So give us 48 degrees, 5 minutes, 58, degree, 5 minutes, and 43. So what we see here is, if we just want the degrees, 90 degrees, or whatever degrees is, if we don't have minutes, if we don't have the second, don't put the degree there. Otherwise, it is wrong. Right? So to make sure this is the complement plus that, I will take that out, and that is 90 degrees. If it is just 90 degrees, we don't put the degree there. It's just 990, right? So the degree by itself, don't need to put anything there. Convert alpha to decimal degree. So alpha is 46 degrees, 42 minutes, and 12 seconds. Alpha plus, and we just hit equal, and that's pretty much it. Or if we want to do that by hand, 46 degree, 42 minutes, and 12 seconds. We have 46 degree, and then plus the minute is going to be divided by 60, and then the 12 seconds divided by 3600. When we do all of that, we should get that decimal degrees. Right. So actually we just I think we should take 5-minute break here, and then we'll continue in 5 minutes. If you have any question, please type on the chat, and I will answer. try to improve. Right, we continue. Three. Right, so the angle in the standard projection 8 definition. Right, when we talk about the standard projection of an angle, the vertex is at the origin. And initial sign is at the positive x-axis. So we have the coordinates here. The positive x-axis is here and the y-axis there. So what we have is the vertex have to be at the origin, and the angle, the initial ray, have to be in the positive x-axis. So we start from here initially, and then we can rotate by default is counterclockwise. So in that case, this angle is in the standard position, vertex is at the origin, initial sign on the positive x-axis. Right. And with that, with the x-axis and the y-axis, divide this into 4 quadrants. And now we just draw this quickly here. We call this is quadrant 1, also counterclockwise, 2, 3, and 4. Right. By the way, how the video, I saw some lacking here. It's okay now. It's back to right. So again, 0 to 180 is half a revolution, and half of that is 90 degrees, and half of 180 back to 360 is 270. So that pretty much. Of course, we might have an angle that go around, and around, more than that. Right. Sorry about that. It should be normal. I can see the frames wrapped. Right. Example. Draw an angle in standard position. And determine the quadrant. Right. So first, 45 degrees. To just sketch that quickly. Right. 45 degrees. We know it's going to start from the angle will be at the vertex. 45 degrees is going to be somewhere in between 0 and 90 degrees. So it is somewhere in here. That's where we say 45 degrees. And that angle is in the first quadrant. First quadrant. Right. Next. 120 degrees. So we start from here. And when we go to that is 90 degree, right? Oh. So that is 90 degrees, a quarter of a revolution. And then we go a little more, about 30 degrees. If we go all the way to the horizontal line here, that's 180. So it's not there yet. So it's somewhere in here. So that is 120 degrees. And that is in quadrant 2. My stream lagged a little bit before, but it should be okay now. I need more room here. Okay. So this one negative, so it have to be clockwise rotation. Positive is counterclockwise, negative is clockwise. So that 90 degrees, a quarter of the circle. Half of the circle is 180 degrees. So we'll go 180, negative 180 already. And then we're going to stop at 210. Right. So, and of course that still end up in quadrant 2. So again, negative is clockwise rotation. Next 405 degrees. Right. So again, vertex at 0, and we start this one positive, so clockwise. 90 degrees, 180, 270, back will be 360 degrees, and we have to go a little more. In particular, 405 minus 360, that's 45 degrees. Right, so it will be like that, and it stopped there, so the angle will be here. So we go around and an extra 45 degrees, so that is 405 degrees, and that back to quadrant 1. Next, coterminal angles. Right. By the name of it, they will have the same terminal size. And of course, by default, the angle in the standard position, they have to have the same initial sign. So we meaning same initial and terminal sign. Right. So I'm going to draw one example here. Let's see, we have that angle. Initial, final. So initial size here. So I could go clockwise as long as start and end at the same ray. I'm good. So I could also go an extra revolution and stop there, and I can go around and around and around as long as I start and stop at the same sign. We're good. So with that, we can say we have an angle and plus n times 360 degrees. 360 degrees is one revolution, so we can go an extra 1, 2, or 3 revolution, doesn't matter, or could be counterclockwise as well. So n is the integers. Meaning that can be negative 3 or negative 2, negative 1, 0, 1, 2. Right. So pretty much the whole numbers could be negative. Oh, I mean, this is the initial and this is the final. It doesn't matter as long as we start from here and stop there. We can go around and we stop, or we can go clockwise or counterclockwise. So initial ray and the final ray. So the angle in red, in blue, or in black here, all of them are coterminal angles. Yeah. So the initial and the final, both of them are here. We do not change the angles. We not change the rays. What we change is only change the direction that we go from it. Right. We'll see more of that in this example. Sorry, cannot see that. Right. So let's say we have 490 degrees. How do we get to a coterminal angles of that? So, if we have an angle, we add 360 degrees to it, we will have a coterminal angle. We can add or we can subtract. So usually if we have something that big of a number, we just subtract 360. Try to bring that in between 0 and 360. So we do that and we have 130 degrees. So 130 degrees is coterminal to this. And 130 is between 0 and 360. So we just subtract. We just subtract 360 degrees or add 360 degrees to it. So we can go clockwise and counterclockwise. For example, if we have an angle like this, we can add an extra revolution, or we can subtract a revolution from it. As long as we start and stop at the same point, we're good. So in this case, negative 150. If yes, the video should be able to available later, probably an hour. Yeah. So we can add 360 or minus 360 to it. So 210 degrees. So 210 degrees and 150, those two are coterminals, because we just go on extra revolution. Same thing here. Thanks for answering that question. Right, so we're going to find two coterminal angles. One of them, so two coterminal angles, one positive and one negative. That is coterminal to 120. So we start with 120. Like what we have here, if we add 360 degree to it, we have a coterminal angles. So now if I add 360, I have 480 degrees. And that 480 degrees is coterminal to 120. We can always add or subtract. The reason why we add 360 here, because the question asks us to bring it to 0 to 360. So we want it to be positive between 0 and 360. So that's why we add. So if it's negative, yes, I should add 360. If it's very big number, I will subtract 360. Usually, ideally, we want the angle to be between 0 and 360 within the first revolution. So that's why we add here and subtract there. Both of those two between 0 and 360. Right. Next, we have 120. Right. Of course, we can add 360, and if we want to, we can just add another 360 to it. And that is 840. And that angle is also coterminal to 120. We can just keep doing that. However, what we want here is the angle that is negative. So if we just add in 360, will not be enough. So in that case, if we want it to be negative, then we have to subtract 360, and that equal to negative 240 degrees. And if we want to, we can keep subtract 360. But the question only asks us for one positive, one negative. So that's good, those two. Right. So we can add 360 or subtract 360 as long as we start and stop at the same position. We're good. Yeah. Yeah. 4. Angle and lines. I'm not going to write out all of this because that's not as important. So coplanar lines. Coplanar lines meaning on the same plane. And next I'm just going to draw the pictures. What next is called the vertical angles. So if I have two lines that intersect, the angle here and angle here, those are called vertical angles. And vertical angles are equal. Of course, we can also have this angle opposite to this angle. So those two angles also called vertical angles, and are also equal. C. Parallel lines and transversal. Right. Not going to write out everything. So we have two parallel lines, and we have a line cut it. It is called the transversal. And in that case, this form a bunch of equal angles. So we see this angle is the same as this angle, and the same as this angle, because those two are vertical. Those two are the same. I'm just going to mark them the same, because also the same as this angle. So all of these angles are equal, and there's some certain name for it, but like I said, it's not that important. Or we can also have the angle in here and the angle here add up to 180 degrees, because it is a straight angle. Same thing here. So the angles either add up to 90, angles either are supplement or equal. That's what we know. So we just pick any two angles formed by the transversal and two parallel lines. Either they are equal or they are parallel. Either they are equal or supplement. Right. With that, we finish the first section. Let's go to section 1.2. The first few sections is just like this, on a bunch of definition. But later on, there will be a lot more examples. As always, denote the section clearly, so at the end we can keep track of everything. Triangles. First, triangles. Right. A triangle is a polygon, three angles and three sides. Three vertices and three sides. I'm just going to draw it by hand. Right. By convention, we use capital letter for angle. Angle is uppercase letter, and the size is lowercase, and opposite to the angle. So opposite to the big angle A is the little a, opposite to B is the sine B, and opposite to C is the sine C. The C and the C kind of difficult to distinguish. So usually when we talk about the angle C, I'm kind of make a little loop like that. Right. Capital letter angles, lower case letter are signs. B, some facts. The first one, on the angle, add up to 180 degrees. By the way, in high school, when we talk about the measure of an angle A, we write like that. But I'm not using that. The international convention is when we talk about the angle A, just use a capital letter. We do not need to put the angle in front, and we do not need to put the measure of the angle A. All of that are redundant. Just say A is an angle A. We know that. And then 2, triangle inequality. Meaning that if you take any two sides, add them up, it's always bigger than the last one. If you take A and C, add them up, it's going to be bigger than B. And if you take B and C, add them up, it's going to be bigger than A. The reason is, if we have one side that is way too long, and if we have the other two sides are too short, these two short sides will not meet and make a triangle. So one side cannot be too long. Otherwise, the other two will not touch to make a triangle. So that doesn't work. One side cannot be bigger than the other two. Next. Just say the bigger angle will face the longer side. We don't need this now, but later on it will be very useful. Right, the area of triangle, we don't even need that now. Right, first example. Find the angles. Right. So here we have the measure of angles. And of course, when we talk about the measure of angles in a triangle, the first thing will come to mind will be they add up to 180 degrees. So we have 70 degree plus 39 degree plus x plus 26 degree plus x have to be 180 degrees. And combine like terms, 70 plus 39 plus 26 is 135, and x plus x, that's 2x. Right, subtract 135 on both sides. So we have 2x equal to that 45 degrees. And divide by 2 on both sides, we have x equal to 45 divided by 2, which is 22.5 degrees. So we solve for x. The question did not ask for x. The question asked for all the angles. So all the angles are, all the angles are, we have 70 degrees, 39 plus x, so we have 39 plus 22.5 will be 61.5 degrees. So one angle, another one, and then 26 plus x, that's 48.5. Right. So those are the three angles in this triangle. Next, classification. By angles. Right. Acute. Acute triangle, if all angles are acute. Of course, acute, meaning that between 0 and 90 degrees. 2. Right triangle, if one angle equal to 90 degrees. And obtuse, triangle, if we have one angle bigger than 90 degrees, meaning one angle is obtuse. Oops. So we have equilateral triangle. Oh, sorry, that's E. Equilateral. So this is classification by size. Equilateral, equal, meaning the same, equal, and lateral, meaning the side round. So all the sides are equal. Isosceles triangle. 2 of the 3 sides are equal. If 2 sides are equal, then 2 angles also are equal. So, and then the scaling. All the measure, all the sides are different. Right. So we classify by the angles. If we have one right angle, that's a right triangle. If we have one obtuse triangle, that's obtuse triangle. Otherwise, we have acute. And then the sides, if all are equal, equilateral. If 2 sides are equal, isosceles. If all of them are equal, if none of them are equal, scaling. Two. Now we focus on right triangle. So in a right triangle, so we have a triangle. That one angle is a right angle. And opposite to that, we have what we call the hypotenuse. And the other side we just call legs. The longest one is the hypotenuse. Is the longest side and opposite to the right angle. Right. Pythagorean theorem. So say we have a right triangle, and the 2 legs are B and C, and the hypotenuse is A. Actually, the way we do that, we name A here, and then here's C. So C is the hypotenuse. It doesn't matter. Pythagorean theorem, meaning the hypotenuse square is equal to the square, the sum of the square of the 2 legs. And then the converse is also true. Meaning if C square equal to A square plus B square, then the angle C is a right angle. So, two things here. Right triangle give us this, and this give us right triangle. So they go both ways. And this is called the converse. So, once again, the right triangle give us this identity, and this identity also give us the triangle. All right, let's look at the proof here. I only do one proof, the one with the square. So we start with a square like this. And let's say we have A and then B. And then B and A. B and A. B and A. Right. So we have four right triangle. We have A, B. The remaining side must be C. So we have C here, the hypotenuse. Right. So we start with the big triangle. I mean the big square. The side is A plus B. So the area is A plus B square. Is A plus B times A plus B. I'll multiply this out. A times A square. A times B, AB. B times A, and B times B. So of course, we multiply it out. So give us A square plus 2AB plus B square. Right. So that is the area of the big square, right? Now, if we write that differently, I'm trying to draw it. We're going to have this. Since each number of them is C, the area of that is, okay, so right. So the big area is given by a side square, A plus B times A plus B. So the area is equal to a side square. Right. So that big square, the area is given like that. So if we don't want to calculate like that, we can desample. That square is the side C, and then there will be four triangle A and B. So the area of the square here is c square, and the area of a triangle is 1/2 base times height. So we have 4 times 1/2 base times height. So that equal to c square. 4 and 1/2 times together is 2ab. Right. Now, since both of this calculation, both of this are equal, because both of them calculate the area of the big square. The big square. So now we match them. They are equal. So we have a square plus 2ab plus b square equal to c square plus 2ab, and subtract 2ab on both sides. We have a square plus b square equal to c square. Right. So this is the proof of the Pythagorean theorem. Right. By the way, I'm going to write out the note at the end of the semester. I'm going to ask for the picture of this proof. At the end of the class, at the end of the semester, I will ask again. But for now, I'm going to ask for this copy of this proof. Right, that is section 1.2. So at the end of the semester, you may see something like this. Proof of Pythagorean theorem, section 1.2, subsection 2c. And that is exactly what we have here. Right, so that is what I asked for at the end of the semester. Right, so with that, I thought you will have a better idea of what I will ask for at the end of the semester. Right. This proof I'm going to skip because we have we are a little bit behind schedule even on the first day. Next. Sorry, that was confusing. This will be D. Right, so we have a 24th letter. Placed 10 feet away from the house. From a house. Reach the top of the chimney. The question is, how high is the chimney? Sorry. Right, so I'm going to draw here. We have a house. Let's say it's like that, and the chimney kind of one side. This is the chimney. Okay. And we placed a ladder. This is the 26-foot ladder. And it is 10 feet from the house. And the question asks us how high is the chimney. So we're going to find this. Height of the chimney. So this very simple. We have Pythagorean theorem because of the right triangle. 26 is the biggest one, is the longest side. So we have x squared plus 10 squared is equal to 26 squared. And we solve for x squared. 10 squared is 100. 26 squared is 676. Subtract 100 on both sides. X squared equal to 576. And to solve for x, we take the square root of that. Square root of 576 is 24. I should say plus or minus square root of 576 equal to plus or minus 24. 576. So plus or minus 24. And we're going to take the positive only because the measurement cannot be negative. So the height of the chimney is 24 feet. So it is about 3 o'clock, so I think I'm going to stop here. So now you get a good idea of what our class should go. Like I said, I might have to go more than 2 hours, and I know it might be too much to ask you to sit there for more than 2 hours. So that's why I put this video on YouTube, so it will be available later if you want to watch it later. And I have a lot of other options as far as the video go. I could use Skype, Google Hangout, Collaborate, and Zoom. But the only thing that I'm comfortable with, where I can put a lot of things, I can put my face cam and the document camera, the calculator, and all other things. So I'm comfortable with doing this on YouTube. So all of the bells and whistle, like what we have now. I think only YouTube has that option, so that's why I save that on. I put that on YouTube. By the way, for the next day, I will have my Google Hangout. We will open. If you have any question, you can always call in and talk directly to me. But most of the time, it will be like this. Right. Thank you everybody for being here. I hope everybody doing well during this time. And if you have any question, please send me an email. And I'm going to end the stream here. And see you on Thursday at 1 o'clock. Have a nice day.